Okay, so recently one of the biggest additions to Ollama has been the addition of structured outputs. So they've had a JSON mode for a while, and that worked to a degree with some things, often not always getting exactly what you wanted and stuff like that. But what they've done now is like a fully supported structured outputs. And more importantly, it allows you, if you're using Python, to basically set up classes with Pydantic to structure how those outputs are going to come out. What I want to do in this video is I want to basically go through what this is, look at some code examples for simple stuff, and then also look at how you could build an app using a vision model to basically extract out text and information using the vision model in a structured way so that we can use that in our app. Often I'm seeing people really trying to do over engineering of things with agents when really what you want is just a good little app that you can call that can do a specific task for you and then deliver a result back for you. Then that can be used by agents for other things and for stacking things up. But often you don't need any sort of agent framework to do this. You can just come in and write the Python code or the JavaScript code to do exactly what you want in here. So let's jump in and have a look. So the big difference with structured outputs is this really allows you to do a structured sort of parsing of either text or extracting data from images, from that kind of thing, doing things like NER, doing things like custom NER and stuff like that. And if you've got a large language model that's good enough for doing this, you can get some really good results. And of course, with Ollama now, we can do this all locally on our machine without having to call any external APIs, etc. So I'm going to show you doing this with a number of different models, looking at some of the results we get out. And then we'll finish up with just a little app that will use a vision model to be able to extract out data from the back of album covers to extract out the song titles and stuff like that. So basically to do this in Ollama, you just need to use one of the more recent versions of Ollama. I think Ollama keeps updating so much lately. I think as long as you've got a version that's reasonably recent, you should be fine. And you'll see that this can be done either with their Python SDK or with the JavaScript library that they've got for this. So the JavaScript library just quickly uses Zod. The Python SDK is using Pydantic. And for me, this is why this is a big change, is that you can take a lot of this code and reuse it quite easily. One of the other cool things that I will show you in here as well is not only can this be done via the Ollama SDK in this way, it can also be done using an OpenAI endpoint. So if you've done this kind of thing with OpenAI models before, it's very easy to swap over to doing it with something that you can basically do locally and run the whole thing locally on your machine. Or of course, if you wanted to, you can actually run Ollama quite easily now in serverless instances. Google Cloud Platform has the ability to run serverless Ollama models. So where you can basically spin up your own model and run it in the cloud where you're just getting billed for the time that you're using on it rather than leaving it running all the time, etc. And that can be with a GPU as well. Yeah. All right, so you can see from the example here, it's very simple to do. We're just going to basically bring in Ollama. We're going to bring in the base model. We're going to define our class. That's the key thing, is we'll either define just one class or we'll often have multiple classes where one class is going to basically use other classes in there. And then we can just pass in the format that we want to take this Pydantic class and have model JSON schema in there. And then we can validate that coming out and print that out, or we can do things like index into it to just get the information that we wanted to out of this. So let's jump into some code examples where I'll walk through how to do this, etc. Okay, so let's look at the first example here. Here we're going to be doing sort of entity extraction. And we can basically do this a number of different ways. We can just set up a class. In this case, I'm just setting up a really simple class called NER. It can do organizations, products, people, locations in here. And you can see what we're going to do is just take that NER and then pass it in there. We're then going to validate on the NER, and then this is going to be used, and we're just going to print out the different things. So let's look at this. Okay, so just running this here, we're basically going to be extracting out the NER for what we've got here. And you'll see that with this model, it's going to be a bit hit and miss for certain things. So it's done a good job of getting the organizations, Anthropic, OpenAI, Google. It's done a good job of getting some of the products, Claude, 3.5 Haiku, O1, O1 Mini, Gemini. It hasn't done a good job on this time of getting the GPT-4 and 4.0 mentions in there. And people, it's done, yes, it's got the name David Jones. The organization Artificial Analysis, it's missed that one, and it's got USA in there. Let's just try running it a few times. You will find that, okay, I could probably improve this by putting in a system prompt in there, and also by, using a specific model. So one of the key things here is that while we're using Llama 3.1, this is just the off-the-shelf version of this. Okay, you can see that now I've changed it to Llama 3.2 3 billion, and we're getting actually better results for the products out of this. We're getting Claude being considered a person, which is funny in there. You want to experiment with this, but with the cool thing with something like this is you could make a data set very easily with something like Gemini 2.0 or one of the other models that will be actually probably a lot better at this task, and then just fine tune this model here to be really good, especially on the types of NER that you want. So you shouldn't look at this necessarily as being like, oh, it works or it doesn't work. You can just look at this as a starting place and then start iterating from there. All right, so another thing you can do with this is we can run the exact same thing. Let me change this to Llama 3.2 in here. So we can run the exact same thing in here, but now we're getting it to respond as if it were an OpenAI endpoint. Before we were using the normal Ollama SDK, now we're using it as an endpoint. So this could be a really good way if you want to put it in the cloud, in like a microservice or something like that. This is a nice way to do this. Let me just run it. This should basically do the same thing. Let's just open it up and see. Okay, sure enough, this one now has got, and you see this one's actually doing better because we're getting the system prompt coming in. So we're getting an organization's artificial analysis, Anthropic, OpenAI, Google, products, Claude 3.5, GPT-4, GPT-4o, Gemini, and Pong. Don't know where Pong is mentioned in there, but I guess it's in there somewhere. Sure enough, a quick check, Pong is mentioned in there. So just by adding this system prompt to it, it's doing much better already in here. And then David Jones. So it seems to be doing much better when we add the system prompt in it for this. Now, this is doing it as the OpenAI version, but fundamentally it's still the same as doing it as the Ollama SDK version in there. All right, let's move to the next one. So this is going to be a picture that I just took at a bookstore where it's just got a whole bunch of books in there. I'm curious just to see, okay, what can it actually get out of these books? And will it be able to tell us anything useful about the books? You can see here, I'm going to pass that in. I'm passing in a system prompt. You're a precise image description system. Your task is to carefully describe images, including objects. It's a very generic prompt in here. In fact, I might have even taken it from what they were doing there before. But the idea is we're going to pass that in. And then here we've got our custom prompt of analyze this image, describe what you include any objects and stuff. Now, I haven't actually mentioned anything about books. So I could probably improve the results by mentioning books. But I want you to see that in this image description, we're passing in books. And we've got like a book object. So this is nesting objects inside one another. So here we've got a book object, we've got title, author. It's going to give out like a confidence score for that. Okay, so the image description, I've been playing around with it for different things. Here I've basically set it so we can get a list of books that are in there, a summary of what actually is in the image, the scene, a number of books with giving it some enums to just give it either single, few, many, and then some settings and stuff like that. And you can really try out a whole bunch of different things in here. You can see we're passing in the Llama 3.2 vision model in this case. We're formatting it with the image description, and we're going to have a system prompt. We're going to have the detection prompt here. Again, this can probably be improved a lot just by mentioning books in these things. I've just taken the basic ones for this and started to play around with it. And then we're printing some stuff out from the books in here. So let me run this. And it will take a second just to basically fire up that vision model. So this is the smaller of the two. I'm not running the 90 billion vision model. I think it's the 11 billion vision model in here. Obviously, it's a quantized version, so it won't get results as good as perhaps the bigger model should get. Okay, you can see now it's come back. It's basically given us the image shows a bookshelf with various books on it arranged in rows. Number of books, many. That makes sense. Okay, books detected. Anatomy of a breakthrough. Okay, if we look at that, sure enough, that's one of the books that is in there. The next one, the author is Adam Atler. Okay, so it got that one right. The next one, Purposeful Curiosity. Okay, yes, it's gotten that one, and it's also gotten the name for that one right. So it hasn't gotten any of these ones on the side. Now, I wonder if we prompted it to look for things sort of text straight up, we might be able to get some better results out of that. Certainly colors present, it's gotten those, it's detected some text of those two books and stuff going through. All right, lastly, I want to do a little mini app in here and just show you a few things about how you can put this together. Okay, so this whole thing is just plain Python. You don't need an agent framework for something like this. You can basically just have this run and have it go through and generate on a whole bunch of different files and stuff like that going through this. All right, so the main thing here is what we're going to be doing is taking album covers, or rather the backs of album covers, where it shows you the track listing, etc. And we want to extract out the track listing. And you can see here that we're going to use a modified prompt. You are a precise image description and transcription system. Your task is to carefully read the text in the image and extract out album details and song details that you can detect. You'll also provide a transcription of the raw text in the image. And then for our other prompt, I've stuck with the same one. Again, this should be, you could tune this certainly to get better results. We're using the Ollama 3.2 Vision, again, the small model, and we've got this set up to this album, validate, etc. as it goes through. All right. The models, you can often put those in a separate file. Here you can see I've just basically got those two different models in a separate file. One of the things that I've done here, which can help a lot, is adding descriptions to the fields. So rather than just have the plain fields of album, title, string, you can actually put in a description. Now, if you're doing anything a little bit more unusual, this will definitely help the model extract out what you want. And this works not just for Ollama, this is for any of the models. That the more that you can do structured output with descriptions of what it is that you want, the more you're helping the model. So we're getting out the album title, we're nesting a song in here. So we're going to have a list of songs, right? For this, that should be coming back. Songs can have duration. So I experimented with duration in seconds, or where it was an int versus duration as a string. You could certainly play with this a lot more to work out which one is better. Obviously, this one is a lot more human readable. So for now, I've gone with that in setting up the models in here. The other thing I've got is a utils file just to basically save this out to markdown files as we're going through this. All right, so our main thing is just one function, and we can basically just pass in a list of files. So you can see here, I'm just passing in a list of Miles Davis album covers. Let me get it started. And sure enough, it's going to go off and start processing each of these. And then we'll return back, saving them into a folder. So let me come back when it's finished. We can have a look at the outputs here. Okay, so it's just finishing running off now. I thought we'd look at some of them. So this was one of the ones, and it's done a pretty good job at the track list. In fact, I think it's gotten the track list totally correct. Looking at this, it's gotten some things wrong. So we can see the other info, the CVS number should be 450965, should actually be 450985, according to this. But it's done a pretty good job at that one. And this one, you notice it didn't have any times. So it didn't hallucinate any, because we structured the output to stick the times on only if they were sort of available in there. If we look at the next version of this is, I think it's a reissue of the same thing. You can see this one, we've got times. The times look like they're matching up. 407, 510, 337, 203, 317. It's done a good job at getting these out. So let's make it a bit bigger so you can see this. And then for some of the transcript, it looks like it's done an okay job at getting this out, but maybe, it's certainly missing some parts of that. This is actually very blurry, low resolution PNG in here, so not the best one for looking at that. And then finally, it's done one there. So, okay, just quickly to show you what it's done here is it's basically made a markdown file for each of these things where we've got the detail about it. And you can imagine now we could put this into a database. We could do a whole bunch of different things. And I just thought this was like a good, simple, easy to explain example of how you could take something like this and just take a whole bunch of image data, process it through where you're looking for very specific things and be able to put them in. Now, if you fine tune the Llama image model, etc., you can actually fine tune it to get a lot better at certain things. If you wanted something to be able to count coins or to look at coins and add up how much is there or something like that, you could actually do a lot of fine tuning with that and then still use it this way and still bring in the fine tuned example into Ollama so that you're running it locally. So the real best way to get a lot of things out of this is to actually go through and play with both the system prompts, but also play with the models, try out different models, try out different fine tunes of models. The cool thing with something like this is once you've got it down, you can just use it again and again and again. You can just have this something that it just runs as a background job to go through your images, extract all the things that you want, put them into a database, put them into a RAG system, that kind of thing. So the structured output certainly opens up a nice way to be able to deal with this kind of thing in Ollama with local models and to be able to do some of the things that really before required uploading your images. And certainly that's something that a lot of people don't want to do, not just for the cost. The costs are definitely coming down, but just from a privacy aspect as well. This allows you to do something that is totally private. All right. As always, if you've got any questions or comments, please put them below in the comments. I'd love to hear how people are using this. I know some people have taken some of the original video that I did on sort of Llama OCR and done a bunch of different projects with it. That's really cool to see. I feel like you can take it to the next level now with these structured outputs and to be able to get much better results. And like I said, the next step from here would be to basically fine tune the model to get it even better for this kind of thing. Anyway, as always, if you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.